while, but we're back. Hello. Today we're going to do the Conservation of Energy Challenge Lab. Let's look at this. Holy moly. There's a huge track. And this is where we'll be starting. You're going to need a cart. This thing right here, this is actually going to interact with the computer to let us know how fast it's going. You're going to need a scale to measure the mass, a ruler to measure the height. What we're going to do is we're going to predict what the velocity is going to be right here when the car makes it all the way down the ramp. We're probably going to have to look at some equations. What do you think, Mr. T? Anything that they should know right off the bat?
Well, to start, conservation of energy, kinetic energy plus potential energy, should be the same at the top of the ramp and at the bottom of the ramp.
Ooh, I like that. Yeah. Yeah, so it looks like kinetic energy plus potential energy here should be the same as kinetic energy plus potential here. Yeah, that's smart. We're definitely going to need that.
Okay, so to start, we're going to kind of help you out, get you started here. Now, we've looked at the equations. We've seen them before. So we're going to look at potential energy and kinetic energy up here at the top. Now, potential energy, of course, deals with the object's location relative to the ground, in this case. So we're going to have to measure the height that it's starting at. So using the height, we can use the acceleration of gravity and the mass of the car to find the potential energy of the car up top. All right. So if we sit here, we have our meter stick. We can get a pretty accurate measurement. So it looks like we have...
Mr. T, where are you measuring to?
I'm measuring to the top of the track.
Really?
Yeah.
Oh, okay, that makes sense. I guess that's where the car is going to be, right?
Absolutely.
Oh, okay.
We'll be resting on top of here. You don't want to measure to the table because the car is actually higher than the table.
Oh, right, okay.
Yeah.
Okay, so that makes sense. So that'll be our H at the top?
That'll be your H for
Okay.
potential energy, yeah.
What else do we need for potential energy?
Well, we need the mass of the car.
That's why they have the scale there.
There's the scale.
Oh, that makes sense.
We can mass the car on the scale. All right, make sure it's zeroed. We can get
Okay, then you
accurate
get your mass. I got you.
Yep. All right.
So we'll get the mass, we'll get the height. What else do we need?
Well, the equation for potential energy is mass times gravity, the acceleration of gravity times the height. So the acceleration of gravity, which of course is constant, we're going to use 9.8 meters per second squared.
Okay.
And with those three quantities, we should be all right with our potential energy
Gotcha.
at the top. Now, the total energy is kinetic plus potential. So we have to think about the kinetic energy at the top also.
Kinetic energy at the top. What is that?
Well, we have our equation, 1/2 mv squared, mass times velocity squared. So we think about the situation up top, with the car moving.
I don't think it'll be moving at the top.
Right, probably not initially.
Oh, okay. I think I know where this is going.
We'll keep that in mind as we go ahead.
So what we're going to do is we'll measure the potential energy and the kinetic energy at the top, but the kinetic energy is 0. And then we'll come down here and we'll do the same thing. Oh, I need a meter stick. Let's see. So you measure to the top of the track, right?
Yes.
Okay, so I guess I'll do the same thing. Measure to the top of the track. Okay, so that'll be my height here. And I'll use G again. And I'll use my mass, and that'll be potential energy here. And you said potential plus kinetic at the top should equal potential plus kinetic at the bottom.
That's right.
Okay, so I guess if I do that, potential plus kinetic, and I get a number, and then I come down here and I measure my height, and I multiply it by z, and I multiply it by m, my mass, then I'll get potential energy, and then I can subtract that, and I'll have what the kinetic energy should equal.
That's what it should be.
And then, I think I see it, and then I can just solve for v.
That's right.
And that's how, okay, love it,
That's how
love
we
it.
can do it.
And then we'll just, I guess after the groups have their prediction, we'll have them test it out.
That's right.
Oh,
Sounds
we've got
good.
to launch it. Let's do it.
All right.
Let's do it in slow-mo with your camera.
All right.
Okay, so here we go. I think we're ready to launch. Miss T's going to get an awesome shot over there as it comes down. Here we go. So, Mr. T, Mr. Martin, signing off.
We're out of here.
That's right.
Hope you learned something, and hope you enjoyed yourself.
Yeah. Hope you took notes. If you didn't, go back and rewind. Write it down so when you come into class, you're ready to go. You're looking for the velocity at the bottom. Any parting words?
Good luck.
Good luck. That was awesome.